Well, hello to everyone, I'm Kate and that's my first breakdown ever. So let's start. But before diving into the actual graph, I would like to talk about what kind of detail I was looking for when starting this project. So here I have some reference. So what makes an object look like it's an old and damaged concrete block? First of all, there is some small edge damage, so you can see even on quite new concrete slab there is some. There is also some larger damage, usually near the corners or near the edges also. And also sometimes there are some leaks. You can see them on these concrete blocks. So here they are, leaks. So that's what I was looking for. Small edge damage, large edge damage, corner damage, and some edge leaks also. So let's dive into Houdini graph now. Here I have some testing geometry and also the generator itself. It has one input for proxy geometry. It's just a simple geometry which is then turned into the concrete block. And it has three outputs. So the first output is a preview. It gives color information about where large damage will be and also where the damaged corners will be also. It's mainly for preview purposes if the user changes some of the parameters, like how many corners are damaged, how deep is the damage, or some parameters for edge damage noise. So here there are some sliders like for noise frequency, noise offset, and so on. So the second output is low poly geometry. It's the actual game model. It's UV'd. So here are the UVs, just simple auto UVs. And then the last output is high poly geometry for baking. So it has all kind of detail and also masks. So here it is without color. So let's dive into the generator. First of all, here is the input. Like here it is. The first thing I did was cleaning up, just cleaning up paths. So firstly I converted the geometry into VDB. It's just for the cases where the geometry is subdivided not very nicely, or I don't know, it has some weird intersecting geometry and so on. So it's just really a cleaning up path. So I converted to VDB with rather small voxel size. Then I converted it back to geometry. So here is clean geometry. And then I remeshed it. What I wanted from the remeshing is to have more geometry near the edges of the block where the main damage is, and less geometry in the center of large polygons, like for optimization purposes. So firstly I measured curvature. So here it is. Then I blurred it a lot, because large damage is actually rather wide. So there should be white stripes of high poly geometry. Then I used the attribute triangle just to harden the edge of this curvature. So just gave some threshold and made all the curvature above this threshold equal to 1. And then I created target mesh size attribute according to curvature. Target mesh size is the attribute which is understood by the remesh node. So while remeshing, it will use this attribute for edge length of new geometry. So here you can see the difference in density. Near the edges, the geometry is much denser than in the center of the block. That's what I was looking for. I also have stash. It just bypassed. It was stash is like caching, so it was just not to do this cleanup pass every time I changed anything in this graph. Then I started working on edge bulges. So first of all, a bit of more cleanup. I just fused points because sometimes remesh node gives some broken points. So it's just cleaning. Then I gave this block some points normal because these normals I used later for the actual displacement of points. Measured curvature one more time to have an arrow stripe near the edge. Blurred it just a tiny bit this time, and then I had this attribute warp to create the actual bulges. So here is the warp itself. Actually, I used noises a lot while working on this project, and I won't talk about them in detail. There is a very good video about working with noises on Houdini Vimeo channel. I'll just put the link in the description. And if you want some more information about noises, I definitely recommend watching that video. It's very good. So here, first of all, I used bind. It's like inputting some attributes. So here I inputted curvature. Fitted it so it became a bit harder. And then just multiplied it with some noises, some distorted, ramped noises. And used it for the actual displacement. So that I had some nice breakup in these edge leaks. Here is one thing I would like to talk more about, and that's this world orientation of these leaks. Because if you look at reference, you can see that sometimes these leaks, they are just on some sides or just on top, so they are not everywhere along the edge, so they have some world orientation. So here I have simple parameters, vector parameters. They just represent some world axis, so like y, x, and z. Then I used dot product, and I fed normal into one input of dot product and this volt axis into the second input. Dot product gives 1 if vectors point in one direction and -1 if in opposite. And the vectors are perpendicular, then it's 0. So I used absolute function because I wanted these leaks to be symmetrical, like top and bottom or both sides and so on. Fitted just to make it harder. And then I just used switches for every axis with this promoted parameter, just to give the final user opportunity to decide on which sides of the geometry these leaks should be. So then I added these dot products, then I fitted everything, so it's 0 to 1, and then also used for displacement. So here I have amount and scale, they are just like multiplicators of each other. And then I just fed the position to the position global output. So here are the bulges. Then I had corner damage and edge damage, small and large. So first of all I needed to select edges that I would use for damage. Because if the geometry is subdivided, for example, like if it has some these diagonal lines, some flat edges, usually there is no damage on them, and also there is usually no damage on these concave angles. So I needed the way how to find only convex edges. Oh, by the way, it's just like switching sides. So here is the usual view. So for edge points I took the actual input non-subdivided geometry. Then I divided it a bit. I used Blicker polygons so that geometry is equally subdivided. Then I gave it some normals, point normals, one more time. I needed them for later use. Then I measured curvature, and then I used polypath node to get rid of actual polygons and get like this edge wireframe. And then I just deleted edges that I didn't need by curvature threshold. So then I resampled everything, and I used create only points toggle because I didn't need the actual edges. I also used a tangent attribute and named it up. So at this stage I had both vectors needed for orientation of objects while copying them. So both normal and up vector. So here you can see the actual up vector, the actual tangent goes along the edges. And the normals were given earlier. So here they are. Then I fused, because resample node seems to give some overlapping points, like I don't know if you can see, but there are some of them. like points sitting in the same spot. So I just fused to clean them up. And here I had the actual points for edge damage. Well, you might ask why didn't I use this group node with edge angles. The problem with that node is that if there is an object with some concave angles, selecting edges by angle will select them also, so it wasn't what I wanted, so I just used curvature threshold. Yeah. So, small edge damage. First of all, I needed a p-scale attribute just to give some noisiness in the size of copied geometry. So one more time, it's just working with noises. I also connected the final result into CD or color output just to have the preview. I also have global multiplicator, which is promoted to the global interface. It's just for final user to decide how much of this small edge damage he or she want to get. So, and then I used find expert to export p-scale attribute. Then I copied boxes. I wanted boxes and not spheres because boxes give more of these chipped look, like edge was damaged piece by piece. So it gives more of this noisiness. And of course, there are already normal and up vector. The geometry is oriented perfectly, as you can see. So then I converted these boxes to VDB, smoothed a bit, reshaped a bit, or just eroded. Used volume warp to give some noise. It's just one more time working with noises and exporting actual surface. You can see here is surface attribute. Then I converted back into geometry, displaced a bit more using usual attribute warp this time, and got the geometry for small edge damage. It's used for booleaning from the slab later. So large edge damaged. One more time, just attribute warp for noisiness, global multiplier, and binding, or I would say exporting p-scale attribute. So here it is. This time I copied spheres. Then I just cleaned everything a bit by deleting inverted geometry, so the geometry which has p-scale less than 0. Then I used VDB from polygons, and I actually toggled fill interior on. I'll explain later why. So volume warp, just to distort everything a bit more. And then I converted, but this time I converted VDB into volume. That's why I needed this fill interior on. So, and then I used the attribute from volume node. I fed into it actual slab with edge bulges. So you can remember it's this subdivided near the edges geometry. And I got the actual depth attribute. Actually, it's negative when the geometry is inside the volume and positive if outside the volume. So I promoted this attribute from points to primitives, and I just grouped these primitives. So here they are. Here is the actual group for edge damage. So then I smoothed this group. So in this way I got this already a bit damaged geometry. So here you can see it looks like it has some damages already. And then I used another attribute warp to create large damage. So I didn't want it to be very deep. I wanted to still have some of form of this block underneath. Actually just inputted depth large attribute, fitted it, ramped it, and by the way, by changing the form of the ramp and the multiplier of the amount of displacement, it's possible to get different forms, different depths of this damage. So then I used clean node. I used it to fix overlaps, and I didn't switch on remove the generate primitives so that I had no holes. Why I needed to fix overlaps? That's because I used this object for Boolean fracture later, and it seems like overlapping geometry causes some issues while Boolean. So then I used polyfill. It's just for safety purposes, just in case there are still some holes. And then I deleted all the unused attributes, so I had clean geometry for Boolean. Then corner damage. First of all, I needed to find corner points this time, so I just used non-subdivided geometry one more time. Just input geometry, gave it point normals, transferred the curvature which was found for edge damage, and then I had two ways of deleting points I didn't need. So first of all, I deleted by neighbors count. What this function does, it finds the points that are connected to this particular point by edges. So like these corner points have 3 neighbors each. And that's the usual case, at least for some simple rectangular block, that corner points have only 3 neighbors, not more. So I just removed every point that has more than 3 neighbors. But that's not always the case, especially if the geometry is subdivided. So I just used switch to allow switch this way off, and the switch is promoted to the global interface of HDA also. Then I used another attribute wrangle, and this time I removed by curvature threshold exactly like for edge damage points. So then I just deleted some random points, so I just used random variable depending on ptnum or the number of the particular point. I used some threshold which is promoted to global interface, so not all the corners are damaged. So if the point is removed, then the corner is not damaged. Then I moved the remaining points. I also gave a random up vector so that the planes, I used just mountain planes for Boolean corners, and I wanted them to be oriented randomly, and that's exactly what this sample direction uniform function does. It gives a random vector. So I used that with lead geometry, but keep the points, so I got only points. Then it's like first Boolean iteration, I just copied simple non-divided grids. I needed them just to get points for the second Boolean iteration, because you know when the corner is damaged, it's like it's damaged in some iterations. So like firstly it's damaged once, and we got new corners, and then they are also damaged, so there are several iterations, and every time the object becomes rounder and rounder and rounder. So I decided to do 2 iterations of this fracturing. So I copied these grids to points, used Boolean fracture. It's like Boolean in shutter mode, but it also gives piece attribute, which is very convenient for me. Then I measured area per piece, used this name attribute, and I just plasted small pieces. And I promoted the inside group from primitives to points for the second iteration of Boolean. Then I gave normals to these new points, and actually did everything the second time, so just deleted some random points according to threshold, moved the remaining, and gave them a new random up vector. Then used that and copied this time these mounted planes. I also used them for the first iteration, just copied to the original points, and then merged both iterations together. So these are the planes that I also used for the Boolean. Then I merged them with these small edge damaged pieces I created earlier. Used attribute delete to delete attributes I didn't need, and performed actual Boolean fracture. So I just used this slab with edge bulges and large damage. And then I measured volume. It seems to me that both volume and area work for these purposes. So I just blasted small pieces, so you can see. And then, because these mountain planes were not very high poly, the lower the poly count, the better is Boolean result, and yeah, less time it takes. So I didn't subdivide them very heavily. And so they are rather high poly, and the Boolean parts are also rather low poly. And I wanted to add a bit more damage, so I needed more high poly geometry. So I just remeshed this inside group. Then I fused it back, because while remeshing it was detached from other geometry polyfill, just for safety purposes one more time. Then point normal for later displacement. Attribute warp, which gives more of this noise on damaged parts. Then one more attribute warp for stones. Here I just used Voronoi noise, which was heavily clamped, so I got like not cells but individual stones. These stones are rather small, so it could be a better idea to just use material with some stones for damages. So I just put here the switch node, which is promoted to the global interface, so it's possible to avoid stones. Sorry. Then I also exported stones mask attribute here, promoted it to primitives from points, and just created a group for stones. It's for later use for creating masks, like ID mask. So I just created empty group of group stones. That is the syntaxes for this thing. It's just like an integer attribute. Integer attribute group and then the name of the actual group. And then if stone's mask attribute is above some threshold, then the primitive is in this group, so the attribute is 1. So normal is just for preview purposes. It can be easily bypassed. So then VDB, they are for cleaning up everything and for making detail a bit more crisp. It seems to me that VDBs just enhance the details a tiny bit. The voxel size is very small, so I didn't lose any detail. Then I reshaped VDB a bit. It seems to me that a small amount of eroding enhances details even more. Then I converted everything into geometry one more time. And then I had some final detailing, so just several noises for this, like a small amount of bumps. Then I scattered some points on the surface of geometry, gave some random scale, copied some mounting spheres to the points, and booleaned them from the actual slab. So these details are not necessary either, so I just used one more switch to allow the final user to switch them off and to use just material, for example, while texturing. Then I used group transfer node because all the groups were destroyed while VDB. So I transferred damage group, inside group, and stones group. And then I just used the attribute triangle for creating masks. It's completely okay to use color nodes. I just wanted to practice some wax a bit more. So I gave everything just blue color first of all, so it's standard RGB, so red, green, blue. And if the current primitive in group damage or inside, it becomes green, and if it is in stones group, it becomes red. So nothing too fancy. Then I transformed the geometry so that it sits on top of the grid. So here is just this minus y min variable. And that's the actual output for high poly geometry. For low poly geometry, I just took this transformed final high poly geometry. I just deleted unnecessary attributes, poly reduced it, and by the way, the number of points is also promoted, so that the final user could decide how much low high poly geometry he or she wants to have. So when I used Swap Auto UV, it's from Game Dev Tools, and it gives these nice UVs, rather nice for automatic unwrapping. Then I wanted one more thing. I wanted to have soft and hard edges according to the borders of UV islands, so for baking purposes. So first of all I used vertex split attribute by UV, so just splitted the edges that are between the UV islands, so splitted the actual geometry. Then I gave everything normal with angle of 180. I was interested in vertices normal this time, so it made all the normals inside of islands perfectly smooth. Then just another normal node with this seams group. Actually vertex split gives this group, this seams group. It's the actual edges between the UV islands. Sorry. So group seams I just gave them normals with cusp angle of 0, and then I fused everything together, and I just switched off the computer affected normals, so they just remain hard. And that's the output for low poly. One more thing is preview. It's rather a simple thing. I just took this first iteration of booleans with no subdivisions, divided it a bit with brittle polygons one more time to give it more geometry, and then used attribute from volume, attribute promote, group expression. So it's exactly the workflow I used for this high poly to damage it, to give it these large damages. And then I just used color node to make everything white, and then I just gave the damage and the inside groups this black color, and also transformed so that the geometry is sitting on the grid, and that's the output for preview. So actually that's all for this concrete block generator. I hope it was helpful for you. If you have any questions, please leave them in the comments here on YouTube or on my ArtStation, and I would be glad to answer them. So that's all for today. Goodbye. Have a nice day.